In this video, let's practice applying our understanding of opposites, absolute values, and comparing rational numbers together. For questions 1 through 8, we're going to go ahead and write the numbered position at each point on the vertical number line. Alright, so for number 1, we have A. If we take a look at our number line to the right, we can see where A is located. It's right over here. Now, we have to figure out what rational value this is going to be. So we have 0 over here and 1. So it looks like A is going to be a decimal or a fraction. For the purpose of this video, I'm going to go ahead and use a decimal. So if we go halfway between 0 and 1, this would be 0.5 or 0.50. So A would be at 0.75 or 3/4 of the way there. So we can go ahead and say that A is going to be located at positive 0.75 or 3/4 of the way from 0 to 1. Now for number 2, we have B. Now B is located right over here. That is right halfway between 1 and 2. So right in the middle, that would be at 1.5 or positive 1.5. I'm going to go ahead and write it as 1.5 here. If we take a look at C, C is going to be located in the negative part here. So I'm going to go ahead and scroll so we can see where C is going to be. Notice it's going to be down here. It's between -2 and -3. So this must be -2.5 or -2.5. And while G is at -2.25 or -2.25, C is going to be at -2.75 or -2.75. So I'm going to go ahead and say this is going to be located at -2.75. That's where C is located. Now moving on to D, let's see where D is. I think for number 4 we have D. It's going to be located right over here. Now let's see here. We at -1 right here, -2. So we know it's between -1 and -2. So it's going to be -1 point something. Here's -1.5. And while this is -1.75, this is going to be -1.25. So D is going to be located at -1.25 on this number line. Let's check out number 5. Number 5, we have E. So for E, we can see that's located, let's see, it's right over here on the positive side of the number line. And so E is going to be right between 2 and 3. So right in between is going to be 2.5. So positive 2.5. For number 6, we have F. So let's see where F is located. Looks like it's just below 0 here. So here's 0 and here's -1. So let's see, halfway would be -0.5 or -0.5. So F must be at -0.25, -0.25. All right, cool. Moving on to G. We look at G here. G is going to be located down here in the negative part of the number line. Looks like here's -2, and we also have -3 here. So here's -2.5, so this must be -2.25, -2 and 1/4. So -2.25. Okay, go ahead and put all these numbers in parentheses to show their location. Now for H here, for H, it looks like we are going to be on the positive side of the number line here. So here's 0 and here's 1. H is right in the middle at positive 0.5 or positive half. So I'm going to say positive 0.5. All right, for the next set of problems for numbers 9 through 16, we're going to go ahead and plot each of these points on the vertical number line to the right. So let's go ahead and use that same number line. So let's see, for number 9, we have I, which is at positive 2.75. So let's go ahead and put that over there. So 2.75 is going to be right over here. I'm going to go ahead and label that as I. And just to be a little bit more clear, I'll go ahead and put it on the left side of the number line. And then for J, we have 0.25. So that's just going to be slightly higher than 0. So each of these is 1/4. So I'm going to go ahead and put J right over here. Okay. And then for number 11, we have K, which is at -2.9. So we're going to have to do some estimating here. So -2.9 is going to be between -2 and -3, but a lot closer to -3. -2.9 would be somewhere like this, really close to -3. So that's going to be where K is located. Now for L, we have positive 2.25, so we have to go to the positive part here. So where's 2.25? Well, each of these lines is 0.25, so here's going to be where L is on top here, between 2 and 3. For number 13, we have M, which is going to be at 1.75, positive 1.75, so it's going to be pretty close to 2. So I'm going to go ahead and put a dot right here. That's going to be M. For number 14, we have N. That's going to be at -0.75. So I think that's going to be right here, between 0 and -1, and it's going to be a little closer to -1. So that's going to be N. And then for number 15, we have O, which is going to be -1.75. That's going to be definitely closer to -2. So it's going to be down here. And that's going to be 0.0. And then finally, we have point P, which is at -3. -3, let's go ahead and see. That's going to be located all the way down here, really close to K, right? So I'm gonna go ahead and put that dot right here. That's gonna be P. So P and K are very close together, but P is slightly lower on this number line than K is. All right, let's check out this next section here. For numbers 17 through 20, let's go ahead and simplify each expression, then compare each value using an inequality. All right, so for number 17, we have this absolute value of 6. Now the absolute value of 6, that's just going to be how far is 6 from 0. So the absolute value of 6 is just going to equal 6 if you go ahead and simplify it. Then if we take a look at this other expression, we have the opposite of 5.99. Now the opposite of 5.99 is negative 5.99, but the opposite of that is going to be positive 5.99. Okay, now if we go ahead and write an inequality, something you could go ahead and say is that 6 would be greater than positive 5.99. That's something you could write. You could also say something like 5.99 is less than 6. So either of those would be okay to write. For number 18, we have negative 5.29, and we have the opposite or the negative absolute value of 5.92. So on the left here, this can't really actually be simplified. It's just the opposite of 5.29, which is just negative 5.29. Right? But if you take a look at the expression to the right, this one is a little bit more complicated. So the absolute value of 5.92 is just 5.92. That's how far it is from 0. But then if you take the opposite of that, that's going to be negative 5.92. All right, so how are we going to go ahead and compare this? Well, we could say something on the lines of negative 5.29 is going to be bigger than, because it's closer to 0, or more to the right on the number line, than this negative 5.92. And another way you could say this is that negative 5.92 is less than negative 5.29, or it's more to the left on the number line. For number 19, we have the negative 4.2, or the opposite of the opposite of the opposite of 4.2. That's our first expression here. And then we have the second expression of the opposite of the absolute value of the opposite of 4, or the negative absolute value of negative 4. Two ways to say it. So on the left side here, we have this 4.2. The opposite of it would be negative 4.2, and the opposite of the opposite would just be back to 4.2. And then the opposite of the opposite of the opposite would just be back to negative 4.2. So this would be the most simplified way to write this expression. And then for this second expression here, we have this opposite of the absolute value of negative 4. So the absolute value of negative 4 is just positive 4. Then if you take the opposite of that positive 4, that would be negative 4. So this would simplify down to just being negative 4. Now, using an inequality, one way we could say this is that negative 4.2, that would be less than this negative 4. That's one way to write it. Or we can say that negative 4 is greater than negative 4.2. For number 20, we have the opposite of the opposite of the absolute value of the opposite of 7.25. That's going to be our first expression. And then the other expression we have here is we have the opposite of 7.5. For the expression on the left, the absolute value of this negative 7.25 is just going to be positive 7.25. But if you take the opposite of positive 7.25, that's just going to be 7.25. Okay. If you take a look at the expression to the right, we have the 7.5, but then it's the opposite of it, and that's just going to be positive 7.5 or 7.50, up to you if you want to keep the 0 or not. Now, if you're going to make a comparison here, we can hopefully say and agree that 7.25 is going to be less than this positive, also 7.50 or 7.5, or you could turn this around and say that 7.50 is greater than 7.25. For questions 21 and 22, let's go ahead and simplify each expression, then order the original expressions from least to greatest. All right, so if we take a look at this negative 8.75, can't really do anything with that. It's just the opposite of 8.75, which is negative 8.75. If we go ahead and take a look at this next expression here, we have this opposite of 8.4. That we can just go ahead and simplify to say that's going to be positive 8.4. Taking a look at this next expression, we have the opposite of 8.9. Simplifying that, we're just going to say that's going to be negative 8.9. Okay, if we have three opposites of a positive number, that's going to be a negative number. If we take a look at the 7.8, well, that's just hanging out as 7.8. There's not much to do with this one. You can leave it alone. For this next one here, we have this absolute value of 4.9, but we have the opposite of whatever that absolute value is. The absolute value is positive 4.9, but the opposite of that is going to be negative 4.9. Finally, we have this negative 4.4. Can't really do anything with that. It's just the opposite of 4.4, which is negative 4.4. Now to identify, we are trying to go from least to greatest here, so from the smallest number to the greatest number, or if we were looking at this on a number line, from all the way to the left to all the way to the right. So let's try to see the smallest one first. So we have 4 negative numbers here. Which one would be to the left, all the way to the left to the most? I think it's going to be negative 8.9. So I think this is going to be the smallest value here. Okay. And then we're going to say negative 8.75. That's going to be a little bit bigger than it. Then looking at our last two negative numbers here, negative 4.9 is going to be a little bit bigger. But then negative 4.4, out of all the negative numbers, it's going to be the biggest of all the negative numbers. Once we've kind of ordered those first 4 values, we have 2 positive values here. Which one's going to be the next biggest? I think it's going to be the 7.8. And the largest value here is going to be positive 8.4. All right, so these are all of them in order from least to greatest. But again, the directions do say that we're going to go ahead and order these original expressions, not the simplified one. So let's go ahead and order them from least to greatest here. So the first one is going to be the opposite of the opposite of the opposite of 8.9. That's going to be the first expression. So go ahead and put a check mark here. We took care of that one. The second expression here, or just value, is negative 8.75. That was what we were given originally. Our third one is going to be the opposite of the absolute value of 4.9. It's good to practice kind of saying these two. Okay. Then after that, number 4 is just going to be negative 4.4, or the opposite of 4.4. Okay. And then for number 5, this one's pretty straightforward. It's just 7.8, positive 7.8. Didn't have to do anything there. And then finally, our last expression here was the opposite of 8.4. So that's just negative 8.4. So these are going to be our 6 expressions ordered from least to greatest in terms of their value. This right here would be our answer. All right, number 22, we just got another one of these, so let's go ahead and practice this one more time. So let's see here. For 22, this first expression here, we have the absolute value of negative 5.7, but then we have the opposite of that. So the absolute value is going to be positive 5.7. The opposite of that is going to be negative 5.7. So, okay, that's the most simplified way to write that one. This negative 5.9 is already kind of just hanging out here, so we're just going to leave it as negative 5.9. Taking a look here at this 5.3, this one's actually kind of good to go too. Leave it alone, it's just this positive value. If we take a look at this fourth one here, we have the opposite of this 5.4, which is just going to be a positive 5.4. I'm gonna go ahead and put some commas between these in case it's confusing. And then we have a long expression here. So let's see, we have to first find the absolute value of negative 6.2, which is just going to be positive 6.2. So we have a positive number, and then we have the opposite of the opposite of the opposite of that positive number, which would just be a negative number. So it's going to be negative 6.2. All right. So again, 3 opposites is always going to get you a negative value. Then we have one more expression here at the end here. We have the opposite of this negative 2.8. That's one way to think about it. And that would be positive 2.8, because the opposite of a negative number is a positive number. Okay, so out of these ones, which ones are going to be the smallest? Well, let's look at the 3 negative values first. Out of these 3 negative values, negative 6.2 is definitely going to be smaller than the other 2 values. That's the smallest. Then between this negative 5.7 and negative 5.9, which one is a little more to the left on the number line? That would be negative 5.9. And so negative 5.7 is going to be the biggest of all of our negative numbers here. And then out of our 3 positive rational numbers here, 2.8 hopefully is more clear that this is the smallest of the 3 positive ones. And then 5.3 is a little bigger. And then 5.4 is the biggest of all these rational numbers. So let's go ahead and put the original expressions in order from least to greatest. We're going to start with this long expression here. This is going to be this opposite of the opposite of the opposite of the absolute value of this negative 6.2. That's going to be that first expression. That's the technically the smallest number here. Then once we take care of that one, let's go ahead and take a look at the second one. This one's nice. It's just negative 5.9. Then let's see, number 3 here we said was this the opposite of the absolute value of negative 5.7. Okay. Then the fourth one here is going to be just the 2.8 that we had, but it was really the opposite of 2.8, or the opposite of negative 2.8. That's this one over here. And then moving on to the fifth one, that one was nice. It was just 5.3. We didn't have to do much with that one, just kind of copied it down. And then the sixth one, or the biggest rational number here, is going to be the opposite of this negative 5.4. All right, so this right here is going to be the order of these rational numbers from least to greatest, or these original expressions. This would be the order. All right, let's check out number 23 and 24. We got some application word problems here. So let's go and apply our understanding of opposites and absolute values to go ahead and solve these problems. For number 23, we have 4 submarines are exploring an undersea trench. The depth of each submarine is shown. Use absolute values to represent the distance of each submarine from sea level. Which submarine is closest to sea level? All right, now the directions do say to use absolute values to kind of help us justify our answers here. So let's go ahead and make sure we do that. Keep in mind submarines are going to be underwater relative to sea level. So sea level is going to be 0. So let's see what we got here. We have submarine W. So I'm going to go ahead and just say we have point W. This is going to be located at negative 1.5. Now that's going to be the location of it. Now it says use absolute value. So the absolute value of this negative 1.5, because we're seeing how far it away is from sea level, the absolute value of that is going to be 1.5. So while it is underwater, it's 1.5 kilometers away from sea level. Now what about the second submarine? We have submarine X, that's going to be located at negative 3.4. Now how do we show how far that is from sea level? Well, it's going to be the absolute value of this negative 3.4. The absolute value of negative 3.4 is going to be positive 3.4. So it's 3.4 kilometers away from sea level. Then for submarine Y, that's going to be at negative 2.6. So how far is that from sea level? Well, the absolute value of negative 2.6 is going to be 2.6. So this one's a little closer to sea level, looks like, than submarine X. And then finally, we have submarine Z. Z is going to be located at negative 4. So how far is that from sea level? Well, the absolute value of negative 4 is just going to be 4 kilometers from sea level. Remember, our units here are kilometers, so for each of these we can say this is how many kilometers away each of these submarines were from sea level. And you can see here that 1.5 is going to be less than this 2.6, which is less than the 3.4, which is going to be less than 4. So out of all these submarines here, you can see this 1.5 is going to be the smallest value, or the smallest absolute value, and the smallest absolute value tells us it must be the closest to sea level. So if we go ahead and take this 1.5 kilometers that we just found out for submarine W, we can conclude that submarine W is closest to sea level. On the other end, we could say that submarine Z has the greatest absolute value, which means that it's the furthest away from sea level, or it's the deepest submarine of all the ones here. All right, let's check out number 24. In 24, 3 friends started savings accounts all at the same time with the same initial deposit. The table shows the total change in each friend's account after 2 months. List the friends in order from least to greatest total change in bank account balance. So first of all, keep in mind that each of these amounts here are not how much they have in their bank account right now. It's the amount of change here, right? So if we take a look at this first person of Luis, it looks like after 2 months, it could have gone up and down over time. However, at the very end, we know that she just has $56.84 less than what she had initially. Then if we take a look at Franklin, over those 2 months, Franklin's account could have gone up and down any number during those 2 months, but at the end of those 2 months, it is technically up $28.69. And then if we finally take a look at Hannah's account here, Hannah's account after the 2 months is up $89.12. All right, so it looks like we're trying to find the greatest total change. So again, we're not looking to see who has the most money. We're trying to see who changed the most compared to what they had initially. Now, that means how far were they from zero? Because if their bank accounts were at zero, that means that their account didn't change at all. So if we take a look at Luis's account first, for Luis's account, if we wanted to see how much it changed by, we would use absolute value. So the absolute value of this negative 56.84 is just going to be equal to 56.84. So this absolute number here, absolute value, is letting us know how much it changed by. So her account did go down, but it changed by $56.84. Now for Franklin, how much did Franklin's change by? Well, it's the absolute value of this 28.69. Well, Franklin's did change in a positive way. It didn't change quite as much, right? The absolute value of 28.69 is going to be 28.69. So while Franklin's account went up, it didn't change as much compared to Luis's account. Now finally, for Hannah's account, looks like it changed by $89.12. Just so happens it happened to be in a positive direction as well. So it looks like her account went up, but also it changed the most compared to all three of these. So we can say that the absolute value of Franklin's account here, or the amount it changed, was less than the amount that Luis's changed. So that would be it's less than the absolute value of this $56.84. And then if we take a look at Luis's, that didn't change nearly as much as Hannah's account. Hannah's account changed by $89.12. So Hannah's must have changed the most. So Franklin's account changed the least, Luis's account changed the next least, and Hannah's account changed the most. This would be their names listed in order from the least amount of change to the greatest total change. Alright, so there you have 24 different practice problems where we practice dealing with plotting and understanding some rational numbers, how to compare them a little bit and looking at them on number lines, as well as their applications when we took a look at some absolute values and opposite values as well. If you found the video helpful, please consider sharing it with a classmate or friend who might also find it helpful, and as always, keep with the great work that you're already doing.